Trimmings became mulch and compost for the local garden club, and all of a sudden the cycle started to close. The cost of manufacturing reduced by 20%, and the water coming out of the textile mill was clean enough to drink. It was as clean as Swiss drinking water going in. And so welcome to the next industrial revolution, when you can drink the water coming out of a textile mill, and the trimmings are declared nutrients. For Warren Buffett and Berkshire Hathaway, the Shaw Industries, we developed a carpet with them that is designed, we designed it as well, some of the collections for it, but it's basically a carpet that's designed to be infinitely reusable. And not just the carpet that is taken back and reused, like PVC carpet that's typically done, where you're just recycling the toxins. But what we're looking at is the idea of the top is the nylon fiber, nylon 6, that can be infinitely recycled back through caprolactam chemically, and the base is a thermoplastic polyolefin that's infinitely recyclable as a thermoplastic polyolefin. So these two materials go back into closed cycles. Shaw has the 15th largest truck fleet in the United States and has developed the reverse logistics to take back all of its carpet and make it carpet again. And this is really important. How many of you know how much carpet waste there is in the United States every year? Anybody have an idea? It's 4.5 billion pounds of carpet waste. Now imagine in our country, if 4.5 billion pounds of polymer was designed to go into closed cycles. Think about that. Infinitely reusable. It would mean we'd have indigenous industry. Why is the carpet industry still in the United States when all the other textile industries have moved? Because it's heavy, and it's cheap. And if you take these things and put them back into closed cycles, then they're going to be indigenous American industries recycling these polymers ad infinitum. They might as well be safe and healthy and not PVC, for example. Steelcase, Herman Miller, Hayworth have all got cradle-to-cradle chairs now certified. And the idea of these chairs, for example, is they come apart quickly with material, with tools that you'd find in the kitchen drawer, and they are designed to be infinitely recycled so that all the materials are defined in systems, and they can go back to becoming furniture or other useful products as their lives continue. For Meco Shade and Twitchell, new window shades are not PVC, they're thermoplastic polyolefin. For the U.S. Postal Service, Cradle to Cradle now has been applied on all the priority mail envelopes and boxes. And a product that just came out as a collaboration with Whole Foods and Nestle Waters and Waste Management and MBDC is a new resource water at Whole Foods, which I think you can get here. And the whole idea is to all of us come together as a collaboration to change recycling behavior. So the strategy partly is to make sure that the bottles get recycled. And so there's an experiment going on at the Whole Foods stores using take-back systems to see how much people can enjoy the prospect of having their bottles go back to becoming bottles again or other products, useful products, but really start to ramp up the whole recycling protocols. Because the Chinese are no longer taking our PET and it's piling up on the docks in Long Beach, and there's an opportunity for us to really think about PET, for example, as a technical nutrient, long-term polymer in an intelligent materials pool. We're very excited about the California Green Chemistry Initiative, and this is a picture of their cover of the report, and especially one of the paragraphs there, which calls for California to move toward a cradle-to-cradle economy, to leverage market forces to produce products that are benign by design, a wonderful term, and develop registries, and we're standing by to help here wherever we possibly can. This is a tremendous initiative. So let me just move on to buildings like trees and cities like forests. Wouldn't it be amazing, as an architect, I have to show you some buildings because I'm an architect, so that's what I do. And wouldn't it be great if a building could sort of work with the cradle-to-cradle protocol? And imagine a cradle-to-cradle building where all of its parts had passports, and we could characterize their use in the current building and their potential use in future buildings. Things like that. And so the building life cycle is bigger than the product life cycle. It has material production, the building production, the occupancy and use, and then the material recovery. And in some cases, these would take decades, in fact, sometimes centuries. And so if we look at the history of the site and the stuff that's in it, we might, within a few generations, recycle the furniture 8 times, recycle the systems 4 times, the walls and things 3 times, the building skin twice, the structure once. The site is essentially eternal. And so we see settings for all the different elements that go into buildings, and we honor their use and their longevity. So here's a building we did for the Bernheim Forest in Louisville, Kentucky. The building is all designed as parts that can come apart. It comes out of the forest. It's made by the forest and designed to be disassembled and go back to the natural systems from whence it came. Solar powered and so on. Purifies water. Here's a building at Oberlin College, a building that with its parking lot, solar collectors, and the ones on this roof, make 13% more energy than it needs to operate. So it gives energy to the grid. The idea, this was done quite a while ago, before LEED existed, so it would be LEED Platinum Plus in today's parlance. But it purifies its own water using a living machine designed by John Todd. The building is done for David Orr, professor at Oberlin, and it's operated by the students. For the Gap here in San Bruno, now YouTube's headquarters, a building with an ancient meadow for a roof, designed to be converted to housing in the future. This is the roof. For Herman Miller, a furniture company, a factory where they're restoring the native landscape, and the building itself is designed so that the office workers and the factory workers all share this public street full of training rooms and conference rooms and cafes and things like that. And the performance of the company doubled upon moving to the new building. Doubled. They went from 350 people making $250 million worth of furniture to 350 people making $350 million worth of furniture. They have daylight, fresh air, listen to the Beach Boys, and you can see the outdoors. For Mayor Daley, we helped with the green roof. He wanted to start a green roof initiative in Chicago, which he's done admirably, and we did the first green roof with him to indicate that it was possible. And why not have a city with green roofs? For Nike in Hilversum, Holland, building geothermally powered, where they've removed as much as possible all PVC. The running track goes over the front door. Just do it. It's Nike. It's designed to be housing in the future if it ever changes its use from an office building. For Ford Motor Company, we were given the task of taking the River Rouge plant, which looked like this, and developing a new protocol for manufacturing, where we used nature as our infrastructure and tried to find ways to clean up the soils using plants rather than digging it up and burning it. So we used phytoremediation, and we built the plant there with the world's largest green roof, 10.5 acres. Most of what you see on this roof are daylighting. We developed a new way of air conditioning and heating a large building. These are the 4 wind tunnels that heat and cool the whole building with invisible ducting. The air just moves in a big bubble over the top of the space and then drops out and leaks out of the building in a controlled way to heat and cool the people instead of the building. The reason it was approved so quickly is that conventional stormwater management had already been costed at $48 million with 3 chemical treatment plants and a lot of 4-foot concrete pipes. Instead, the green systems were $13 million and Ford saved $35 million day one, which with the Ford Taurus at a 4% margin out of Chicago is the equivalent of an order for $900 million worth of cars. It was approved in a minute and a half by the board. But here are the eggs, the killdeer eggs, and this to me is the importance of the story, because 5 days after this roof was laid down, the birds started arriving. And it's a very simple roof. See this gravel here? It's only 1.5 inches thick, with sedum growing in it, a succulent that goes dormant for the winter, comes back in the spring, and invited other species to return to the site. And so here's a building that makes oxygen, provides habitat, changes colors with the seasons, so on and so forth. For the National Museum of Science and Industry in the UK, a new museum, $6